In my current session, we will be using OpenGL Programming Guide 9th edition. From this book, we will cover Chapter 5, Viewing Transformations. We are especially interested in matrix, viewing model, camera model, orthographic viewing model, user transformation. I would like to demonstrate how to use matrices in OpenGL programming. In my next episode, we will be using OpenGL for Shading Language Cookbook. We will implement the same program using OpenGL math library matrices. The session after next session we'll be using OpenGL SuperBible 7th edition and implement the same algorithm. By using several different books, we can practice and make ourselves familiar with the basics of OpenGL programming. Hi everyone, my name is Thomas Kim. Today is October 14th, 2022. This is my 106th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL DBB. Please pay attention to how to handle matrices in OpenGL programming. In this episode, we will learn how to use Frustum translate, RotateY, RotateZ, scale, helper functions defined for OpenGL Programming Guide 9th edition. In this book, these helper functions are defined. In OpenGL SuperBible 7th edition, vmath Frustum, vmath translate, vmath rotate, vmath scale, these functions are defined. They are mathematically equivalent, but there is slight difference. In OpenGL Programming Guide 9th edition, if you search for Frustum, click Next. Figure 5.4, you can find a view Frustum. If you scroll down a few pages, you can find Frustum projection. You have to compare figure 5.13 with vmath Frustum. This vmath Frustum is not defined in OpenGL Programming Guide. This library is defined in OpenGL SuperBible 7th edition. So, this book contains some error. Figure 5.13 Frustum projection. In this figure, this function does not exist in this book. This function is defined in OpenGL SuperBible 7. I will explain what is the difference Frustum defined in OpenGL Programming Guide 9th edition and vmath Frustum defined in OpenGL SuperBible 7th edition. This function and this function, they are equivalent mathematically, but there is slight difference. If you want to follow my current session, you must have watched my previous episode, OpenGL Must Learn Songs. Please double-click this link. If you haven't watched my previous video, episode 105, please watch this video. Show more, download current video source code. Please click it. Show in folder, extract the zip file. In the folder, I will rename OpenGL songs. Here, I will rename 106. Now copy, paste it in your working directory. In this folder, double-click this solution. In the Solution Explorer, I will pin down. We created this file in our previous episode. So if you haven't watched it, episode 105, you may have difficulties following my current session. Now press Ctrl F5. It should build and run successfully. Now close it. Close it. Now scroll down. In the private section, GL plot scale factor 1.0 F. Scroll down. You can find onKey function. Here, case glFW key down. This scale factor, we will decrement this scale factor times 2.0 F. Then break. Case glFW key up. This scale factor plus equal this scale factor times 2.0 F. Break. Now scroll up. In the display function, this should be the last call. In this display function, here plot angle. This F time. This function returns milliseconds from the start of the current application. So its unit is millisecond. We will divide 50.f. We will cast plot. Don't miss semicolon. We assume angle in degree. So we are using the time as angle for rotation. This angle is in degree. Const GL plot clear color. Don't miss semicolon. 0.5f, 0.5f, 0.0f, 1.0f. 4 elements. I have to delete this 4 plus to make it comparable with back 4. GL clear buffer FV GL color draw buffer 0. GL plot this clear color. We clear the background. Now press Ctrl F5. It should build and run like this. Now close it. Here we create auto projection. Frustum. This function is defined in the global scope. 1.0 f. This is left boundary. Left clipping region. 1.0 f. This is right clipping region. Negative 1.0 f. This is bottom. 1.0 f. This is top. 1.0 f. This is near Z. 500 f. This is far Z. Right click, go to definition. This function is defined here. Save all. For more information about this function, refer to this documentation. This function and this function, there is a slight difference. I will discuss the difference shortly, so please bear with me for the time being. Open up shader files, cube, vertex shader. I will auto hide. We need to set this projection matrix. Here, GL uniform matrix for FV. This we need this uniforms index. We retrieved this index, projection matrix index, in our previous episode here. So if you haven't watched my previous episode, episode 105, you may have difficulties understanding my current session. Now here, transpose. Please note that Frustum returns 4x4 matrix. This matrix is low major matrix, but this projection matrix used in OpenGL shader, it uses column major matrix in OpenGL shader. So we have to transpose GL true. Transpose converts row major to column major. I will give a line break here. Then value. So we have to provide projection like this. Sorry, I missed one. Count. It should be 1. 1 means one matrix. Please understand, it requires pointer. So it should be either array or pointer. If you are unsure, you can always use debug function. type of projection. Talk, play, fun. Get type category. Projection. NL. Now press Ctrl F5. So the type of matrix 4 is mat4. This is actually array. You can say mat4 A, right click, go to definition. mat4 is defined here. It must have typecast operator. So this typecast operator converts type mat4 to GL float pointer. That's why it works. Now auto translation translate 0.0 F 0.0 F negative 5.0 F. We created another matrix. This is translation matrix. Then auto scale this scale factor scaling to x, y, z directions with the value this scale factor. Now auto rotate y, we pass theta angle in degree. Copy paste rotate G auto model matrix. We first rotate y times rotate z. We have to rotate with the origin. We rotate with respect to origin of the model, our cube. Then scale. We make it bigger. Then we translate. Translation. We translate. Don't miss semicolon. In this operation, the parentheses plays very important role. Once again, the multiplication order plays very important role. Now, we set model matrix like this. GL uniform matrix for FB. We need this uniforms index this model matrix index. Then I made typo here. Count. We are specifying one matrix, so 1. Then transpose GL true. We have to provide column major matrix. So we have to transpose the matrix. Then model matrix. Don't miss this part. Now we draw GL, draw elements, GL, triangle, strip. We created triangle strips for cube. We created 2 triangle strips for our cube. In control home this episode. These are vertex indices. 1 triangle strip, 2 triangle strip. In this video, so count. We need 17 indices. Draw elements. If we scroll up, in vertex indices, we have 17 elements or indices. 8 indices for first triangle strip. 8 indices for second triangle strip. In between, one more index. This index is used for primitive restart. Now scroll down. So we have to provide 17. Then type. Its type vertex indices for triangle strip is GL unsigned int. So we provide GL unsigned int. Then this is offset indices. We can simply provide null. This is offset indices. Now press Ctrl F5. It should build and run successfully. Make it bigger. If you press up arrow, something wrong. Close it. Close it. I think I made a mistake here. Sorry. 0.2, 0.2. Press Ctrl F5. Make it bigger. Now it works correctly. I will close it. How do I know all these things? For example, RotateY, right click, go to definition. Angle theta is converted to radians. So reading this code, I understand the angle is in degree. I read the C++ source code. Also here, we can provide typecast GL plot pointer like this. Or we can pass like this. It doesn't matter. For example, it still works. It works because matrix defines this operator. If this operator is not defined, then we have to pass ampersand like this. Because this operator is defined, we don't need it at all. This should work. I understand all these things because I read the source code.